I'm here to talk to you about adopting Swift incrementally. And really what I want to cover today is using our experience from Etsy as a case study. So I'm going to tell you a little bit about where we began and how we decided to get started with Swift, the experiments we ran to actually start getting into our code base, and then a lot about the lessons we learned and the things we broke along the way. So just really, really briefly, if you're not familiar, Etsy is a global marketplace where people around the world connect online and offline to make, sell, and buy unique goods. And at Etsy, we have 4 native apps. We have an application for buyers, an application for sellers, and both of those are on iOS and Android. But of course, I'm here to talk to you about Swift. So in 2015, when Swift 2.0 came out and Swift went open source, it really seemed to us like it was completely magical. And myself and a lot of other engineers at Etsy started getting really excited about how we could use Swift ourselves. I would look at a class and I would say, this would be so much better if I could rewrite it using generics, or if only I had compile time API availability, then writing this feature would be so much easier. And we started to say to ourselves, well, we could stay with Objective-C, or maybe we should look at rewriting everything. And there have been a lot of wonderful articles from different companies. One from Lyft comes to mind, where they talk about how porting their app to Swift made it faster, it made it smaller, it reduced bugs, made their developers happier. And all of these things were things that seemed magical and exciting to us. And we wanted that too. So we said, great, let's rewrite everything. And we decided to put together a proposal to sort of, over time, incrementally port our app into Swift, class by class. And the first thing we needed to do, of course, was build consensus. So what surprised me is when I talked to people outside of iOS development about starting to use Swift, I really got 2 comments from people. People would say, Swift's been out for like a year, aren't you using it already? Isn't that something that happened? Or people would say, are you totally crazy? Like, why would you rewrite your app from scratch? So gathering consensus was a really important part of this process. And the way we decided to do that was through a process we call an architecture review. And all that means is you write a proposal, and you get a bunch of smart people in a room, and sort of the burden of proof is on you to explain why you think your new code, your new idea is going to make your lives better. And we got these smart people together, and one of them piped up and asked a really astute question, which is, well, how do you know that all this Swift code you write is going to be better than the Objective-C that you already have? And this turns out to be a really good question for us because we actually have a lot of Objective-C. As of August 2016, we had over 5 years of commit history, 280,000 lines of Objective-C and counting, spread across 2,500 implementation files. And I'm excluding our libraries here. And the reason I bring this up is not because it's bad. All of that code represents a lot of experience and authority and expertise with Objective-C. And to my colleague's point, throwing all of that out and starting over might not have been the most prudent approach for us. And we decided we really needed to find an answer to that question. We needed a reason to use Swift that wasn't just because it's magical and cool and exciting. So we decided to take a step back. And we said, well, maybe we don't have to live in one world or the other. Let's just start running our tests in Swift. And that's exactly what we did for 3 or 4 months, is we started writing functional tests in Swift, and we started writing unit tests in Swift, and using that kind of as a vehicle to answer that question. And that led to our first epiphany. When you're moving back and forth between these 2 languages, you start to look at Objective-C and start to realize that it can't really express certain things. You'll be writing a function, and you'll look at it, and you'll be like, what if this argument is nil? Like, will everything break? Probably. And so that really gave us the answer. We said we don't want to use Swift because it's cool. We want to use Swift because we think it's going to let us write safer code that crashes less. And from there, we were actually able to go and build that consensus again. We had another architecture review with a new proposal, and we started to talk to people about kind of our new goal, which was, instead of moving everything to Swift and making Swift development mandatory, let's just make it possible. Because if we believe that the Swift code we write is going to be better and safer, then we could start to write new features at Swift and keep all of that old Objective-C that we already know and trust. So that's kind of what we landed on. We said, instead of living with Objective-C or Swift, let's be a 2-language code base. Let's commit to that. And this is actually a really smart decision, I think, because realistically, if we were porting our app like 1 piece at a time, it would take us years to get from completely to Swift anyways. So why not admit that and commit to interoperability? So there's a lot of disadvantages to this approach. Obviously, it means you're kind of in this awkward in-between code base state. Xcode kind of forgets what language you're looking at and gives you the header for the wrong one. More importantly, developers need to know 2 languages, which is also a disadvantage in terms of education. And finally, we have to deal with all those kind of messy interoperability features like bridging headers and auto-generated Objective-C. But to us, the advantages really outweighed that. If we're adapting Swift piece by piece and just new code, it gives us a lot more time to adapt to risk. It also lets us figure out how Swift is going to work for us. And finally, it gives us time to really learn Swift as an organization. So we know that by the time we write more Swift, we're going to be better Swift writers. And so we needed kind of an approach for how we were actually going to start using Swift at all. And the approach we landed on was Swift by experiment. What we said is we're going to make hypotheses about how we think adding each individual piece of Swift to our codebase will go, and then we're going to find a way to test them. And this was important to us because we knew that things were going to break. And we wanted to make sure that anything we broke didn't affect our users or our actual app in production. And things were going to break for a lot of reasons. The most important ones, of course, are Swift is unstable. It's unstable in the sense that it's under active development, and Apple is still making breaking changes. And also unstable in the fact that sometimes it just crashes. Xcode crashes, playgrounds crash. We want to make sure that doesn't actually cause problems for us in the wild. The other reason experimentation was important is because we realized our app is kind of part of a larger ecosystem. We're not just a Git repository. We also have third-party services like crash logging, and we have to submit builds to Apple, and we have build machines, we have to deal with translations, and probably things we haven't even thought about. And it was really important for us to ask ourselves, for each of these external things that touches our app, how is adding Swift going to affect it? And so from there, we kind of came up with 3 goals. We said, well, first, let's just add the Swift runtime. Then we're going to add our first Swift class and A/B test it. And then only then are we going to start developing new features in Swift. So I'm going to kind of walk you through each of those experiments and what we learned from them. So the very first one was adding the Swift runtime. What I mean by this is when you start shipping Swift in your app, because Swift does not have a stable binary interface, you actually ship all of this libraries, the dynamically linked libraries required for the Swift runtime with your app. And the way you actually do this is when you check a bunch of boxes, and we decided to ship some code that doesn't run. So we added a hidden view controller in Swift, so we'd kind of get the effect of adding all these libraries to our app without actually having users running the Swift. And so the very first important thing we learned here, make sure those libraries are actually there. If you unzip an IPA file with a Swift app, you'll actually see next to the payload a folder called Swift support. And that should be filled with a bunch of dynamic libraries like swiftlibcore.dlib. And if those libraries aren't there, then Apple sends you a nasty email and rejects your app. So save yourself a lot of heartache and unzip it. So it turns out that certain kinds of headless builds, like Xcode build included, don't actually include this folder by default. The same bug exists for WatchKit apps if you've experienced it. So check that first. The other thing we learned here was about monitoring build sizes. So all of those libraries in the Swift runtime, it actually adds up to something on the order of 17 megabytes. It's actually fairly substantial. And I know I wasted a lot of time worrying about, is this going to bump us over the over-the-air download limit, which would affect downloads, and that would be bad. And so I spent a lot of time trying to come up with scripts that would tell me, how big is our app going to be when we submit it to the App Store. And it turns out that's actually really hard because of things like app thinning and Apple compresses it. You can't really answer the question of how big your app is. And the solution to that, of course, is just upload it to iTunes Connect. Deep within all of these menus under Activity, All Build, and you click on a build, Apple will actually tell you exactly how big the app they're going to ship to your users is. So save the time. So after that first experiment succeeded, we decided to move on to running our first Swift code. And this was experiment number 2. And the approach we decided to use was an A/B test. And A/B tests are usually used to test interface features like should this button be red or blue. But what we really wanted to test was Swift itself. And so what we did is a line-by-line rewrite of an existing simple view controller. And what was useful about this is, we weren't testing our ability to write novel code in Swift. We were just testing, Swift itself and how it interacts with the rest of our Objective-C code base. And of course, like all good experiments, this one also taught us something new, which is that it crashed. So I have a pop quiz for you. I'm going to give you a couple seconds to read this and see if you can find where this code crashes. Give me a 1, a 2, or a 3, depending on what line you think it's in. I see a 2. Nobody? Well, it's totally fair if you don't see it because, we didn't see it either. It turns out it crashes here on line 3 when you access the property collection.type. So all of our code, everything outside of this class was still in Objective-C. And what was happening here is collection was an instance of a class that was an Objective-C class that was imported. And we didn't actually add nullability specifiers to it. And what that means is that collection.type came through as property implicitly unwrapped string. And implicitly unwrapped optionals, all that means is it's effectively an optional value that is automatically force unwrapped for you when you try to access it. And this happens before it doesn't give you compiler warnings or anything like that. And what happened is we turned out that the collection.type property, at a certain point in Objective-C, became nil for some small percent of users. And when that passed through into the border in Swift, You try to access it, Swift force unwraps nil, and then the app crashes. So this was a really important lesson we learned, which is annotate your files. And this was interesting for us because, of course, with something like 2,500 header files, annotating all of them was completely impractical. And the solution we landed on was to annotate files while you import them. Because your Swift bridging header is kind of the firewall between your Swift code and your Objective-C. So as long as you annotate things there, you're going to be safe. And a special word of caution, don't forget that headers nest. So a header that imports a header, you need to make sure your Swift annotations are available in all the headers that it links. The other thing we learned here is that our crash logger actually didn't give us useful information in Swift. We were trying to figure out where our code was crashing, and we got sort of this garbage in our stack traces. And it turns out that a really interesting property of Swift is because Swift has proper namespaces, you need to make sure there aren't any naming collisions in the compiler on the linker level. So all of the symbols in Swift actually get compiled to this mangled format. And it turns out that you can actually there's a useful tool shipped with Xcode tools called Swift demangle. And you can take your stack trace and you'll put it into Swift demangle, and it'll actually give you a proper looking stack trace. So with our crash fixed, we decided we were actually ready to start writing new code in Swift. And we kind of came up with a team goal, which was don't write any Swift that another developer would have to rewrite to use from Objective-C. And the reason I say this is because for us, we decided that code reuse was a really important goal. And we didn't want to end up in a situation where someone writes a new and exciting utility in Swift, and then another developer wants to use it in Objective-C half of the code, but they can't. And it turns out this is actually harder than it sounds because there's a lot of features in Swift that are not backwards compatible with Objective-C. Things like generics and tuples or tuples, structures, all of these things that if you have them in your Swift code, then your automatically generated Objective-C header just won't include them at all. But of course, we don't want to tell you not to use these features at all. This is a big debate we had, because these are part of the things that make Swift expressive and exciting and make us want to use it. So the solution we landed on was actually really simple, which is use access levels. So we have private and file private in Swift 3.0. And all we decided is that if you're going to use something like a generic or a struct and so on, just make sure it's flagged as private. So you can write your very Swifty sort of code, but it'll still, the actual interface for it, you're forced to write something that you could still use from Objective-C. The other thing, of course, was how do you enforce this? And the approach we landed on was using a linter. So a linter is just a small piece of software that takes source code as input and outputs style violations, usually things like commas and braces. But you can actually use this to do a lot more powerful things. So I wrote a linter rule on top of the great open source project called SwiftLint. And what all this linter rule does is it looks through and makes sure that you aren't using any of these Swift-only features in a way that's publicly accessible. And if you do, it warns you about it, so we can make sure we keep that code out of our code base. Finally, the last thing we sort of learned is that a lot of our Objective-C code just looks bad in Swift. It's not very Swifty. And it turns out there's this really fantastic macro called nsRefined for Swift. So if you have a piece of ugly Objective-C code, you can actually tag it with this macro and then write an extension in Swift. And that lets you redefine how Swift will actually see that function, so you can make it sort of more canonically Swifty. And if this is an approach that's useful to you, there was actually a great talk, WWDC 2015, called Improving Your Existing Apps with Swift. That goes a lot more into using extensions in an Objective-C-based app. And so that kind of brings me to the future. And we really wanted to make sure we were still answering that question of how do we make sure that the Swift code we're writing is going to be as good as or better than the Objective-C we already had. And it turned out the very first thing we needed was code standards. We wanted to make sure we all agreed on the Swift code we would actually write. And what was interesting is that none of us actually felt like we had the authority to write our own Swift code standards from scratch. This was a new language to us, too. So what we did, and I suggested to you, is, of course, you can borrow some. A lot of companies actually publish their Swift code standards publicly. We actually started with GitHubs. And that gives you kind of a starting point. You take that starting point, and then we started to modify it with our own concerns about interoperability to get to the code standards we have today. Other thing, of course, is don't forget to standardize on a version. As soon as you have more than one Swift developer, you're probably running more than one version of Xcode. And this really isn't a problem in Objective-C, but it quickly becomes a problem with Swift, because you're going to start shipping code, and then you're going to start generating warnings for each other, or it's not going to compile at all because you're all running slightly different versions. So very simple. You can check from the command line what version of Swift you're running, and just agree on one. Swift.org actually now publishes tool chains that you can install into Xcode separately from the Xcode version, or you could just literally say, let's all install Xcode at the same time. Then, of course, we have to deal with future versions of Swift. And adopting Swift 3.0 potentially has all of the same problems of adopting Swift in the first place. It's a breaking change. How do we deal with that? And we decided to keep the same experimental approach sort of on an ongoing basis. We looked at running Swift 3.0 in a branch using the code migrator, as well as installing a future version of Xcode on one of our build machines. And this lets us kind of use the same experimental approach to make sure that Swift 3.0 isn't going to cause us any problems either. And then finally, we have education. And this is something that's kind of ongoing for us, and it's something I'm really excited about, which is, how do we get other developers outside of iOS to contribute to the iOS apps? And so the approach we're taking is to run a series of workshops and lunches where we start to introduce Swift to sort of the larger population. So let me talk a little bit about the bigger picture. If you're sitting in the audience and you have big Objective CM and you want to start using Swift tomorrow, what is my advice to you and where can you start? So the very first thing I'm going to tell you is you need to find your raison d'etre, your killer feature. And what I mean by that is you need a reason to use Swift, and it can't just be FOMO. It needs to be it needs to be something that's actually good for you as a developer, for your users. And once you find that reason, you start telling people about it, it becomes much easier to get other people on board with you actually using Swift in your code. So my next suggestion to you is to start outside of your code base. For us, starting with tools was actually, or starting by writing tests was actually really invaluable. One thing that was really important is it let us actually gain experience with writing Swift. But the other thing that was important is it let us gain experience with writing Swift at Etsy and kind of figuring out, what does that mean for us? And when you start outside your code base, whether it's with tests or tooling or toy projects or anything like that, you give yourself the opportunity to learn as a group. So my next suggestion to you, of course, is to make and test hypotheses. So all the things that broke for us, while they may break for you, you're probably going to find some new ones too. Every system is different and every system is unique. And the only way you can sort of figure out what's going to give you a problem is by trying it. So my suggestion is to sort of make a diagram, figure out all the things that touch your app, and ask yourself, if I add Swift, is this going to change, or how is this going to change? And then for every one of those things, try to devise an experiment to figure out how you can actually test that without breaking your app in production. And the last thing I want to leave you with, of course, is that you can do it. We're really lucky to be working with these two very powerful languages that are interoperable. And it gives you a lot of tools that we might not have otherwise. So don't be afraid to get started. And that's it. Thank you very much.